Alright, so today we are going to start talking about radioactive decay. And the first one in this video, what we're going to focus on, is called alpha decay. And what happens in alpha decay is that we're going to lose 2 protons and 2 neutrons from the nucleus of the atom. And the symbols for this, what you'll see in a nuclear reaction equation, is you'll see a 4 over 2, and then it'll say He. Now why is that? Well, if you're losing 2 protons and 2 neutrons from the nucleus, that's the same as the nucleus of a helium atom, in which the 4 represents the mass number, because mass number is protons plus neutrons, and if you have 2 protons, 2 neutrons, that's where we get the 4 from. And the 2 represents the atomic number, which is going to be the 2 protons. So alpha decay is represented by the fact that you have a helium, basically the same as a helium nucleus leaving the atom. Another symbol for it would be this alpha symbol. Kind of looks like an A. That's another symbol for alpha decay that you would see. What's going to change? Okay, we're going to change 2 things. We are going to change the atomic number, and what it's going to do is it's going to go down by 2 in the original atom because we lost the 2 protons. Then the mass number is going to decrease by 4 because we lost the 2 protons and the 2 neutrons. So mass number is protons plus neutrons, 2 and 2 is going to give you 4. So we're changing both the atomic number and the mass number, and both of those are decreasing. An example of alpha decay, we see right up here 238, which is our mass number for uranium. The atomic number right here is 92. Okay. So what's going to happen if uranium undergoes alpha decay is it's going to turn into thorium, which has got an atomic number of 90, because we went from 92 protons to 90 protons, because that's what happens in alpha decay. We lost the 2 protons. They left the nucleus. Our mass number, you'll also notice right here, decreased by 4. So we had 238, now we have 234. So this is the mass number of thorium. And then, of course, we showed the fact that it was alpha decay by putting the 4 over 2 He. So that was the helium nucleus. It also could show just the alpha symbol, but this is another way to show it. I prefer this way just because this is a great way to check to make sure that you're doing this correctly and that you have the right mass numbers and atomic numbers. Because if you look, we started out with 238 on this side, and now we have 234 and 4 as our mass numbers on the other side, which are equivalent to 238. And mass should remain the same before and after. So if we look down here in our equation, we have 92, and then we show that on this side we have 90 plus the 2, which also equals 92. So that's one way you can kind of easily check to make sure, oh, did I, do this correctly. Another example, we have platinum. So platinum's mass number was 175, atomic number is 78. If it undergoes alpha decay, we're losing the alpha particle right here. So we've got the mass number of 4 and the atomic number of 2, so it decreases by 2 protons and 2 neutrons. And what it does is it changes the element because we're changing that atomic number, so now we have osmium, number 76, which is now going to have 76 protons. The mass number, 171. If you look, we have 175, and then now we have 171 plus 4. So you know that that would be the correct mass number. And then if we look right here, we had 78 as our atomic number. Now we have 76 plus 2, which is equal to 78. So those are all examples of alpha decay. What you're really looking for here is to see either this helium nucleus or, like I said, that alpha symbol. Either one will work. But we noticed that we also changed the mass number and the atomic number. We changed both of those. So that's what we're looking for in alpha decay.